Hey everyone, how are you? In this video, we are going to solve the lead code problem of the day, and the problem is successful pair of spells and potions. In this problem, we are given three different inputs. Two are integer array, one is spells, another is potions, and there is another integer which is called success. Now, these are the three inputs we have. The output we need to give in the problem is for every given spell, we need to find out how many this particular relationship is true. That is, for every spell, how many potions do we have such that spell multiplied by potion is more than or equal to success. We need to return the output as an array. Let us see an example of this. So in the example, the given spells array is 5, 1 and 3. These are the three elements in spells. The potions given are 1, 2, 3, 4, 5. And the value of success here is 7. Now, for every spell, we need to find out how many potions do we have such that spell multiplied by potion, that particular value, the product is more than or equal to success. So the output is going to be 4, 0, 3. 4 is for 5, 0 is for 1, 3 is for 3. And that is why I told you we need to return the output as an array, because for every spell, we are going to have the count of how many spell multiplied by potions is more than equal to success, right? Let us see how the output is 403. So for 5, if I just multiply 5 with 1 and 2 and 3 and 4 and 5, this will be 5, 10, 15, 20, 25. Now these are the different products we have. How many products are more than or equal to 7? The given success, it is 1, 2, 3, 4. So the output is 4. For 1, if you try to find out the product, spell multiplied by potions, it is going to be 1, 2, 3, 4, 5 itself. 1 multiplied by 1, multiplied by 2, multiplied by 3, 4 and 5. So none of these values are more than equal to success. So the output is 0. For 3, the product is going to be 3 multiplied by 1 is 3, multiplied by 2 is 6, 9, 12 and 15. Out of these 5 product values, how many are more than or equal to success? It is 1, 2 and 3. 3 and 6 are less. So we got 3 values, right? And that is the output we need to give. So I think the question is very straightforward. We now understand the question. Now let us try to understand how to solve this particular problem. Now, first of all, let's understand a very important relationship here. The simple thing is we need to find out for every given spell the count, right? That how many potions are there such that spell multiplied by potion is more than equal to success, right? So the relationship is for every spell S and for every potion P, spell multiplied by P, if this is more than or equal to success, then we need to count it, right? We need to count that particular potion. So in terms of the given value P, which is a potion, the P should be more than or equal to success divided by S. I just took this S in the right hand side. So this is going to be success divided by S. So the relationship here is you need to count those portions for which the success divided by S is less than P, or I can say the value of P is more than equal to success divided by S. If this is true, you need to count that particular portion. Let us see this again. If you try to find out for 5, right? Now, how many portions are there such that the portion value is more than or equal to success divided by S? So what is success divided by S? Success is 7, S is 5. So 7 divided by 5 is equal to 1.4. How many values, how many portions are there such that it is more than or equal to 1.4? So we have 1, 2, 3 and 4, right? And the output for 5 is 4 only, right? So we are on the correct path. Now, how is this going to help us? Before we dive into that particular part, try to understand about one very important thing, that portions needs to be sorted. And I will tell you why sorted portions is going to help us. The thing is, the ordering of the portion doesn't even matter. The portions are 1, 2, 3, 4, 5. If I just reorder them, it is 1, 2, 3, 4, 5, right? If I just reorder them, still the answer is going to be same. For example, for 3, how many portions are there such that spell 3 multiplied by the portions is more than or equal to success? So using this particular relationship, I can simply say, try to find out how many portions are there in this particular array such that for a given value of portion P, it is more than equal to success divided by S. Success is 7, S is 3, right? So 7 divided by 3 is somewhere equal to 2.33. So we have 1, 2 and 3. We have 3 values which are more than equal to 2.33, right? We can just go through this particular array and compare it, and compare this particular value 2.33 with each element. So 2 is not more than equal to 2.33, but 4 is, 1 is not, but 3 is, and 5 is. So we got three values, right? And the output for 3 is also 3. So I think this is how we can solve the problem. Now, why sorting is very important? The reason is, if you do not sort your data, if you do not sort your portions, then when you will find the value of success divided by the spell, that is success divided by S, then you will have to go through each element to find out how many data you have, how many portions you have, such that it is more than equal to the given value success divided by S. But if it is sorted, that is 1, 2, 3, 4, 5. If the data is sorted, then you will see how easy it is to find out the output. That is, we basically need to count, right? We basically need to count how many values we have such that it is more than or equal to success divided by S. Now we know that the success is 7. When the S is 3, the output for S equal to 3 is 3. When the S is 5, the output for S equal to 5 is 4, right? So let us find out the value of success divided by S. So in the case of 3, it is going to be 2.33. In case of 5, it is going to be 1.4. If I know this particular value and I want to count how many portions I have such that it is more than equal to 2.33, now since the data is sorted, I don't need to go through the entire data. I can use something called as binary search here. Basically, I need to find out where can I put this particular value in my data such that the data remains sorted. So I can put this 2.33 at this particular point, right? After 2 and before 3. Here I can put 2.33 and the data will still be sorted, right? It is 1, 2, 2.33, 3, 4, 5. Now, how is this going to help me do the counting is, if I put it here, if I put my element at this particular point, then 1, 2, 3. All the elements in the right hand side, those elements will be more than 2.33, right? And that is why sorting the data is going to help. I just need a point where I can put my data, and all the elements in the right will definitely be more than equal to 2.33, right? Similarly, in case of 1.4, where the value of S is 5 and the success is 7, 7 divided by 5 is 1.4. I can actually put 1.4 at this particular point after 1 before 2, right? To make sure that the data is still sorted. So we have 1, 2, 3, 4. 4 elements in the right, and the output for 5 is actually 4, right? Now, the main logic. If you know this particular value, which we will definitely know, we know the value of success, we know the value of spells. We know this particular value, success divided by spell. How can I find the point where I need to put this particular value? For example, if this is 1.4, not 1, just for an example, I know that the portion array is going to be integer array, but just for the sake of clarity, if this is 1.4, where should I put my 1.4? My success divided by spell. I can put it here and still the data will be sorted, and I can put it here and still the data will be sorted. But if I put my 1.4 at this particular point and I count all the data in the right, it is going to be 4. But the output here is going to be 5, because we need to count this as well. Why? Because the relationship is more than equal to, right? So even if it is equal to, we need to do the counting. So we actually need a point, an exact point, an exact index in my portions, sorted portions, such that all the data in the right is more than or equal to, or I can say all the data in the left is strictly less than my success divided by S. Now in Python, there is a direct functionality for this, which is called bisect underscore left. And this is under the bisect module. It does the exact same thing. You give it a sorted data and a target value, and it will tell you the index at which you should place this particular value such that all the data in the left is strictly less, all the data in the right is more than or equal to. And I will tell you how to implement this from scratch as well, but try to understand this. If you know that this is 1.4 and you need to put it here, so it will tell you the index. You need to put it at index number 0. I got total 1, 2, 3, 4, 5 elements in the right. How can I find it? I can simply say whatever is the index at which I can put, and what's my length of the array, it is 5. 5 minus 0. We got 5 elements. Similarly, if the value is not 1.4, if the value is the original value 1, then I need to put this 1.4 somewhere here. So this is going to be 1.4 here. At index number 1, still I can apply the same formula. The total number of elements is 5 minus 1, the index at which I need to place my element to keep the data sorted. 5 minus 1 is 4. This will give us a count of how many elements do we have in the right. So this is how you can actually solve the problem. So now let me show you the solution for this particular problem, and it will look something like this. First of all, I will just calculate the length of my portions, and then I will sort my data, and then I will create a result array or a list. Then I can go through my entire spells. For S in spells, I need to find out the index at which I can put the success divided by S in the portions array, which is sorted, right? So I can use the bisect left function, and this comes from the module bisect. So I can say from bisect import bisect underscore left. So I can make use of this function to find out the index, and for each of the cell S, I can put a value in the result, and I can say result.append L, which is the length of my portions, minus IDX index, and ultimately I can return the value of result. And then I can submit this, and this is going to pass all my test cases. So you can see the runtime is really good. The memory used is really good as well. So we have solved this particular problem in a very easy way, right? Now, for all of you who are interested to find out how this bisect left is implemented, I can actually replace this logic with another logic, another function, which is BL, which does the exact same thing as bisect left. You can see the logic is same, right? IDX equal to BL now instead of bisect left. I'm passing the portions and success divided by S. This is my BL function, and I'm basically using the classical binary search here. The left index is 0, the right index is the length of my data, and I'm going to run a loop till my left index is less than right. I can simply find out what's my mid value, and I can check if the data at my mid value is strictly less than the target. The target T is here. The target T here is the success divided by S, right? In that case, I will move my left pointer. I will only move my left pointer if the data at my mid index is strictly less than the target. Else, I will move my right pointer to mid. And when I'm out of this loop, my left pointer is going to point out to that particular index at which I should put this particular element success divided by S to keep the data sorted and to ensure that all the elements in the right are more than or equal to my current element success divided by S. Now I can submit this, and this is also going to pass all the test cases. You will see that the runtime and the memory used are a little bit more compared to bisect left. Reason being, bisect left is highly optimized. So instead of using this BL, I can directly use bisect left if I just want to improve my runtime and memory. I can submit this, and this is going to be more beneficial and more optimized. So I think we have solved this particular problem, and I hope you understood everything about the problem and the solution approach. And if you did, then make sure that you hit that like button. And if you are not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.